Now this for loop video, I'm going to make things just a little bit more complex. They're not too bad, but we have to be very careful. We have to track variables a little bit more closely. So the first thing I'm going to do is I'm going to initialize some variables, and I'm going to just simply make a equal to 1, b equal to 2, c equal to 4, and d equal to 12. And then I'm going to create a variable, an integer variable called answer, and I'm just going to initialize it to 0 because I want my answer to start at 0. And I'm going to run a for loop. Now the for loop, I'm going to set my counter. Remember, I'm going to set I equal to 1. That's my counter. That's going to keep track of how many times I've run this loop. Now I want my counter to be less than c. So I'm going to run this loop as long as I is less than c. Now the fact that I have done that, and the fact that I am going to put I++ here, if you have basic understanding of for loops, you should know how many times this for loop is going to run, how many times it's going to execute. So remember, it starts at 1, and it's going to increment by 1 all the time. So it's going to go 1, 2, 3, 4, 5, 6, 7, and so on. But it's going to stop if I is not less than c. It's going to stop. So what is c? We look up here, and c is 4. So we're going to operate as long as I is less than 4. By the way, that means it can be 1, 2, or 3. So this loop is going to run 3 times, 1, 2, and 3. When I is 4, it's not going to execute because 4 is not less than 4. And so inside of this loop, though, I'm not going to do an output statement. I'm going to actually have some mathematics occur. So I have answer plus equals d, and then I have answer divide equals 2. I'm just going to start with this mathematics here. And I want to track what my variables are while I work through this. Now, notice first of all that there is a variable a initialized, but it's never actually used in my code. And I don't know if you saw that when I hovered over it here. It actually did give me a quick note that it was not being used. A is just ignore it. It's just there. It's trash. Actually, I could delete it if I'd like, but just don't be confused by it. And actually, the same would go here for B. B is here, but it never really is used. So that's trash. I could get rid of that. And C is 4. That's important. That's here. D is 12. D is used inside this loop. And answer is a variable that gets used. So these are the 3 that are important. Those are the other ones I need to ignore. Now in code, I wouldn't want to delete them. I just want to keep track of it. I don't need them. Sometimes it's nice to build a table, if you will, just to track where you're at here. And so on this table, I'm going to track I, C, D, and answer, if you will. And so I'm just going to track what my numbers are. And I'm just doing this here in the comments just for the sake of you being able to see what I'm talking about, what I'm thinking in my head. In a program you wouldn't write this, but maybe on paper if you're trying to do a more challenging question you could. And so in this loop over here, I start with I equal to 1. So in my table, I is 1. And when I start this loop, I have to remember that C is equal to 4, and D is equal to 12. So C is 4, and D is 12, and answer is 0, remember. Now, the next step is for me to run the code. So I have to remember that I run this code, and I is 1, C is 4, D is 12. So right here, guess what? My answer changes to 0 plus 12. So my answer is 12. And then I need to take that 12 and divide by 2. So it's actually 6. So after this 1 is run, the answer has been changed to 6. Okay, the answer is 6. I need to keep that in mind. Okay, it changed to 6. Now, I move on. I is 2, C is 4, and remember I'm testing to see if 2 is less than 4, and that's fine. D, though, is now still 12. Okay, it has not changed. Remember over here, D never changed. The only thing that changed was the answer. So D stays as 12. And the answer currently was 6, though, so let's keep that in mind. And so I have to go 6 add 12 is 18. and 18 divided by 2 is 9. Okay, and so my answer here is now 9 when I'm done running that code, the second line. Now, this code is going to run one more time. This is going to bring up another key thing here. Now I is 3. Okay, I is 3. We're going to do our test. 3 is less than 4. Yep, that's true. And C has never changed in this program. It's still 4. D has never changed in this program. It's still 12. Okay, and so I come down. My answer currently, my answer over here is 9. So I'm going to go 9. I'm going to add 12. That's 21. And then 21 divided by 2. 21 divided by 2 is 10.5, and if you're into programming or you understand a lot of programming up to this point, you know we may run into an issue here, and I will deal with that in just a moment once I do my output. I'm going to output the final answer at the very end of my program, and so this for loop runs 3 times, because remember, when I get down to this next stage in my table, I is now 4, C is now 4, and once over here 4 is less than 4, once this statement fails, this whole test now just ends. This is just garbage, doesn't do anything, it doesn't even look at it. It stops. And then I output my answer. So I'm going to execute this code and see that the final output is just the number 10. And remember, in our head over here we had found that it's 10.5. Now the key to this is to remember that all of my code used integers. Everything was an integer. And so remember that integer problems will always give integer answers. And I do have a video on mixing data types if you wanted to watch that to teach and explain why that's happening a little bit more and how to handle it. But the fact that I have integers and that I'm supposed to be getting integer answers, that 10.5 is dumped into an integer variable, and there's no memory, there's no room to save that decimal, and so it just gets dropped. So that is why the answer is 10. Now, it's also important to understand that the variable that gets printed here, I could go back and I could print variable like C. Okay, this is very, very important actually, that you understand local and global variables. So C was created right here at the very beginning of my program, and so is D, and so is answer, and so I can access those down here and do any of that and work with them at anywhere in my program, because these are global variables. Global because they can be used anywhere in my entire program. Here, if I use an I and I run this, okay, I get an error. Okay, I get an error because I is a local variable. I is a variable that was created inside the for loop, locally, close to the for loop, inside the for loop. And it can only be used locally inside the for loop. Okay, I cannot access it outside the for loop. It's declared in the loop. It exists in the loop. Once you leave this loop's universe, it doesn't exist anymore. You can't see it. The program says, what on earth is that? I can't see it. It's hidden. And so local and global variables are very important, especially when you deal with loops. If you create it inside, so for example, if I were to create a variable inside of this for loop just for fun, I know that'll mess up my table a little bit, but if I create another integer, m equals 100, and I come down here and I try to access m, and I try to run this, I will end up with the exact same problem. Because m was created inside the loop, it's a local variable. It's inside this loop. It cannot leave the loop. It's stuck inside that loop. And so local variables are fine locally inside of this world here, but they cannot be accessed outside. It's a very key concept that some people make mistakes on in future programming.